Oops. As requested by a number of you, here's a quick video that goes over formula writing and naming. Okay, we're going to start with formula writing. There we go. Which is going from a name to a formula. There are two ways to do this, okay? Ionic and covalent. How do you know which one it is? Ionic is a metal and a nonmetal. And covalent is two nonmetals. Lots of you ask, what about two metals? You won't have that because both metals like to give up electrons. So those electrons have nowhere to go if a metal bonds with another metal. We're going to talk about metallic bonding, but not for a few weeks, okay? So writing a formula, you've got to figure out you've got to basically account for all the electrons. The number of electrons that are lost by one element have to be gained by the other element. With ionic bonding, it's pretty easy to figure out, okay? So you might have something as simple as aluminum oxide. And when I talk about writing the formula, I mean going from the name aluminum oxide to the formula. Like for water, the formula would be H2O, okay? So you need to go to your periodic table and you need to look up the oxidation state of aluminum. In this case, aluminum only has one oxidation state and it's +3. So I rewrite the symbol for aluminum with the charge +3. And that means aluminum loses 3 electrons. Oxide is oxygen. The "ide" just means that it's bonded, okay? This indicates that it's in a compound and not just like random oxygen floating around, okay? So oxygen, you go and look, and since oxygen's the nonmetal, you take its top oxidation state. Oxygen only has one, but for any other nonmetal, those are the ones to the right of the staircase, you would just take its top oxidation state. Then to write the formula, you take the top number of aluminum, drop the sign, put it here. Take the oxidation state of oxygen, drop the sign, and put it here. And what you end up with is Al2O3. What that basically means is that I need 2 aluminums for every 3 oxygens. That should make sense, okay? Why does that make sense? Because aluminum loses 3 electrons, but each oxygen can only gain 2. So in order to make the whole compound neutral, I have to have 2 aluminums and 3 oxygens, okay? Another form of ionic formula writing that you might run into is something like sodium sulfate. Sulfate ends in "ate", okay? It's not just a simple "ide". It's not obviously on the periodic table. When you have something like this, you should look at table E. That means it's a polyatomic ion. Polyatomic ions don't let go of each other, and they don't change their name. So what you would do is you would look up what sulfate is. And if I look up sulfate, I see that sulfate is SO4 2-. Now, I'm going to suggest that you always put polyatomic ions in parentheses. Keep the numbers in the parentheses and the letters in the parentheses, and then the oxidation state, which is this 2- on the outside. Okay? It's going to help you remember what to keep together and what to move. Sodium is Na, and it only has one oxidation state, which is +1. Hopefully you're learning that one because we use sodium a lot. Now you're going to do the same thing that you did before. You're going to flip-flop it. You're going to take the Na and put the 2, because the 2 comes over here, and then you're going to put the SO4 in parentheses. If you don't have those parentheses there, it's not the end of the world. It's really fine. However, you may I think you're going to find that life is a lot easier if you keep your polyatomic ions in parentheses. Finally, okay, we're going to do something that might have a Roman numeral. Now, when you're formula writing, Roman numerals actually make your life easier. So copper 2 hydroxide. This Roman numeral means that copper is +2. It does not mean the second oxidation state of copper. It does not mean that there are 2 coppers. It means that copper is +2. So when I don't even have to look up the oxidation state of copper. I'm telling you it's +2. Believe me. And 2 plus +2 does not make a difference. Okay? Hydroxide is not an element, so this is also on table E. So I'm going to look up hydroxide. I'm going to put it in parentheses. It's OH, and it's minus. Minus means -1. They just are saving ink by not putting the 1. okay? Now I'm going to take the 2 and put it on the outside and take the 1 and put it here. And I end up with CuOH2. Now this is a case where if you don't have parentheses, it's wrong because CuOH2 means that I have 2 H's but only 1 O. Whereas here the 2 applies to both the oxygen and the hydrogen in that parentheses. Okay, so it's kind of like math. So it's important. Keep those polyatomic ions in parentheses, and you should not have a problem. Okay. Now I'm going to talk about covalent bonding. Let me just erase these things. When you have 2 nonmetals, it's actually a lot easier. It doesn't work on this, okay? Because the covalent bonds, they have so many oxidation states, it's almost impossible to tell which one it's using. You know what I could do? Sorry, bear with me. Oh, what did I do? Sorry. So, I've got to use prefixes to tell you how many of each. You don't switch anything. Don't make this harder than it has to be. And you don't look up oxidation states. And you don't reduce. That's something we didn't talk about in ionic. Okay? So, for example, if I said sulfur hexafluoride, okay? What sulfur hexafluoride is? Sulfur, there's no prefix, so I can assume that there's 1. Hexa means 6, and fluorine. So it means SF6. That's it. I'm not taking the 6 and putting it with sulfur. No, it's sulfur, there's just 1. Fluorine, there's 6. Okay? So for example, dihydrogen monoxide, that's water. 2 hydrogens, H2. Mono means 1. Oh, 1 is fine. You don't have to put the 1. Okay? Don't reduce it. What I mean by that is if you end up with N2O4, I'm telling you it's dinitrogen tetroxide. Believe me, don't reduce it. However, if you have an ionic compound, you would reduce it. Okay? So if you had an ionic compound like this, you would want to reduce it. You would have something like, I'll do it in a different color, Mg2O2. If you did magnesium oxide, you would reduce that down to MgO. Because in order to write that formula, you would flip-flop it. You would take the 2 and put it here and take the 2 and put it there. You're looking for the ratio. Remember, ionic things do not form molecules. Okay? They would just form a network, and we're looking for the lowest ratios. Okay. We'll try this. Naming is the opposite. And we talked about naming a little bit today in class. Okay, so when you're naming things, there's a couple things you have to ask yourself. The first question, is it ionic or covalent? How do you tell that again? Covalent has 2 nonmetals. Ionic has a metal and a nonmetal. If it's covalent, you use prefixes to indicate how many of each. So the example there would be if I had S2O8, okay? If I had S2O8, what that would be is disulfur octaoxide. I know that's weird, but bear with me, okay? The 2, I'll use a different color. The 2 is the di, and the oct is the 8. Remember, it ends in "ide." Okay? If it's ionic, the first thing you check for is, are there more than 2 elements? If so, look at table E. That means something is on table E. Pull the name of that from table E and don't change it. Okay? The next thing you check for is does the metal or the positive one, first one, okay, have more than one oxidation state? If so, you need a Roman numeral. The Roman numeral has to indicate what the oxidation state of the metal is. Okay, so for example, if I gave you FeCl3, okay, the Fe is could be +2 or +3. Those are the options on the periodic table. Okay, in this case, it's using +3 because chlorine's -1, and there are 3 of them. Okay, what that really means is that I have 3 negatives. Each chlorine needs to gain an electron, so each chlorine has a negative. I have only 1 iron to neutralize all those negatives. So what's the charge on that iron? Well, it's got to be +3. 1, 2, 3. Okay, it's got to be +3. So this would be iron 3 chloride, where the 3 means that iron is +3. A trickier example would be FeO. Okay, you would think that if you're just flip-flopping this, you think it's iron 1 oxide because there's a 1 here and a 1 here. However, you've got to remember that oxygen's -2. Okay, so if oxygen is -2, that means that 1 iron has to cancel out both of those minuses. So that means that iron has to be +2. Okay, so this would be iron 2 oxide. Where does that come from? If you struggle with this, write a formula for iron 2 oxide. You get Fe2O2, and all you would do is reduce it to FeO, which matches this. Okay. Then put your Roman numeral, figure out what Roman numeral it is if your metal has more than 1 oxidation state, and then finally you would just name the metal, followed by the non-metal ending in "ide." Okay? This is the reverse of what we did before. So this is starting with a formula such as MgO and then writing the name of it. Okay? Magnesium, I only have 2, so this is ionic because it's a metal and a non-metal. It does not have more than 2 elements, so there's nothing on table E. The metal only has 1 oxidation state because magnesium only goes to +2. So I would just say this is magnesium oxide. If you wrote that it's magnesium 2 oxide, I'd give you full credit, but this you do not need. Okay? You only need that when metals have multiple oxidation states: iron, copper, cobalt, nickel. If you're trying to do this without a reference table in front of you, you're not going to succeed. Okay? You really need that reference table in front of you. Hopefully that helped. If you have any other questions, please send me an email.